November 1943. The Hurtgen Forest, Germany. American infantry from the 28th Division advanced through dense woodland when German positions erupted with concentrated machine gun fire. The Americans went to ground, returning fire with their M1 Garand rifles. The German soldiers, veterans of campaigns across Poland, France, and Russia, immediately noticed something wrong. The volume of fire coming from the American line was impossible. It sounded like dozens of automatic weapons, yet these were riflemen, not machine gunners. What the Germans were experiencing was their first sustained contact with a weapon that would fundamentally alter infantry tactics and shatter assumptions about small arms warfare. The M1 Garand represented a revolution so complete that within 2 years of widespread deployment, every major military power would be scrambling to develop similar weapons. But in November 1943, the German troops pinned down in the Hurtgen Forest could only react with shock to the unprecedented firepower now being directed against them. The mathematics were simple but devastating. A German infantry squad of 10 men, equipped with Mauser Kar 98K bolt-action rifles, could deliver approximately 40 aimed shots per minute under ideal conditions. An equivalent American squad, carrying M1 Garands, could deliver 240 aimed shots in the same time frame, a 6-fold increase in firepower without adding a single soldier. This wasn't incremental improvement. This was wholesale transformation of infantry capability. The weapon that created this revolution had emerged from a lengthy and contentious development process. John Garand, a Canadian-born firearms designer working at Springfield Armory, had begun developing semi-automatic rifle designs in the early 1920s. The U.S. Army, observing the horrific casualty rates of World War I trench warfare, concluded that future conflicts would require dramatically improved infantry firepower. The specifications were demanding. The Army wanted a semi-automatic rifle that could match the accuracy and reliability of the bolt-action Springfield 1903 while delivering sustained rapid fire. It needed to function in temperatures from Arctic cold to tropical heat, in mud, sand, and water. It had to be simple enough for conscript soldiers to maintain with minimal training, yet robust enough to survive years of combat use. Most critically, it had to be manufacturable in quantities measured in millions, not thousands. Garand's design, finalized after years of testing and refinement, was adopted in 1936 as the U.S. rifle caliber .30 M1. At first glance, it appeared conventional, a wooden-stocked rifle weighing 9.5 pounds, 43 inches long, firing the standard .30-06 Springfield cartridge. But beneath that traditional exterior lay engineering that was years ahead of contemporary military rifles. The operating system used gas pressure from firing to cycle the action automatically. When a cartridge fired, a small portion of propellant gases was diverted through a port in the barrel into a cylinder beneath. This gas drove a piston connected to the operating rod, which cycled the bolt, extracting the spent cartridge, cocking the hammer, and chambering a fresh round. The entire cycle occurred in less than 1/10 of a second, allowing the shooter to fire as fast as they could pull the trigger. The ammunition was loaded via an 8-round on-block clip that inserted into the receiver from above. When the last round was fired, the empty clip ejected automatically with a distinctive metallic ping, signaling the weapon was empty. This clip-loading system, initially controversial, proved brilliantly practical in combat. A soldier could reload in less than 2 seconds, far faster than stripper clips used with bolt-action rifles. The weapon's accuracy was exceptional. The rotating bolt locked into the barrel extension with multiple lugs, creating a rock-solid lockup that ensured consistency. The gas system was self-regulating, adjusting automatically to different ammunition types and environmental conditions. In testing, the M1 could place 10 shots into a 4-inch circle at 100 yards, accuracy matching the finest bolt-action rifles. But technical specifications meant nothing without production capability, and here, American industrial might would prove decisive. By 1940, with war engulfing Europe, the United States began massive expansion of rifle production. Springfield Armory in Massachusetts and Winchester, Repeating Arms in Connecticut received enormous contracts. New facilities were constructed almost overnight. The production challenge was immense. Each M1 Garand contained 53 separate components, many machined to tolerances of thousandths of an inch. The receiver alone required 35 separate machining operations. The barrel needed precision rifling and chrome plating. Yet by 1943, American factories were producing 4,000 M1 rifles every day. By war's end, over 4 million Garands had been manufactured, each one capable of delivering unprecedented firepower. The first large-scale combat test came in the Pacific Theater. Marines landing at Guadalcanal in August 1942 carried M1 Garands, facing Japanese troops armed with bolt-action Arisaka rifles. The firepower advantage became apparent immediately. Japanese banzai charges, devastating against troops with bolt-action rifles, met walls of semi-automatic fire that cut them down before they could close to bayonet range. Sergeant Mitchell Page, commanding a machine gun position during the October 1942 Japanese offensive on Guadalcanal, saw his entire squad killed or wounded. Taking up an M1 Garand after his machine gun was destroyed, Page held his position against repeated Japanese attacks through the night. His Medal of Honor citation credited the M1's sustained firepower with enabling one man to hold ground that would normally require an entire squad. The rifle had fired over 400 rounds without malfunction, something unthinkable with previous infantry weapons. In Europe, the M1's advantages became equally apparent, but in different ways. The Bocage country of Normandy, with its dense hedgerows and close-range combat, favored rapid fire over long-range accuracy. American infantry could pump rounds into German positions faster than defenders could acquire targets and return fire. The psychological effect was as important as the material damage. German soldiers reported that American rifle fire sounded like machine guns, creating the impression of facing overwhelming numbers. The winter battles of 1944 through 1945 provided the ultimate test of the Garand's reliability. In the frozen Ardennes during the Battle of the Bulge, weapons that had been pristine in warmer conditions froze solid. Bolt-action rifles became single-shot weapons as frozen bolts refused to cycle. The M1, with its gas-operated action generating heat with each shot, continued functioning even in sub-zero temperatures. Soldiers learned to keep one round in the chamber at all times. Firing that round warmed the action enough to ensure continued operation. The weapon's only significant limitation was the 8-round capacity, smaller than the 10 rounds in a bolt-action rifle with 2 stripper clips loaded. But this apparent disadvantage proved minimal in practice. The ability to fire those 8 rounds in rapid succession, reload in 2 seconds, and resume firing created a sustained fire capability that bolt-action rifles couldn't approach, regardless of magazine capacity. German after-action reports from 1944 revealed the impact on enemy forces. Wehrmacht intelligence assessments noted that American rifle sections could deliver firepower equivalent to German machine gun teams. Recommendations included avoiding direct infantry engagements with American troops unless German forces held overwhelming numerical superiority or heavy weapons advantage. The rifle had shifted tactical calculations at the most fundamental level. German attempts to counter American firepower advantages focused on their own semi-automatic rifle programs. The Gewehr 43, introduced in 1943, was Germany's answer to the M1. But production never exceeded 400,000 units, and quality control problems plagued the weapon. Manufacturing complexity meant each G43 required 50 man-hours to produce, versus 20 man-hours for an M1. German industry, already strained by Allied bombing and resource shortages, couldn't match American production volume. The Soviet Union, observing American success with semi-automatic rifles, accelerated development of their SVT-40. But Soviet production philosophy emphasized simplicity over sophistication, and the SVT-40's complexity made it unsuitable for conscript armies with minimal training. By 1945, Soviet infantry still primarily carried bolt-action Mosin-Nagant rifles, accepting inferior firepower rather than weapons that required extensive maintenance. General George Patton's assessment of the M1 as the greatest battle implement ever devised came from direct observation of its impact on combat effectiveness. Patton, commanding the Third Army through France and Germany, noted that American infantry consistently outfought numerically superior German forces in small unit actions. Analysis attributed this partly to superior training and tactics, but the firepower advantage provided by the M1 was cited as the decisive factor in most engagements. The ammunition consumption figures told their own story. American infantry divisions in Europe expended an average of 300,000 rounds of 30-06 ammunition per day during active combat operations. German divisions, with primarily bolt-action rifles, used approximately 50,000 rounds daily. The six-fold difference reflected the M1's capability to deliver sustained fire that bolt-action weapons simply couldn't match. American ammunition production scaled to meet this demand in ways that demonstrated industrial capacity beyond anything Axis powers could approach. The Lake City Army Ammunition Plant in Missouri alone produced over 47 million rounds of 30-06 monthly by 1944. Each cartridge was manufactured to specifications ensuring reliable feeding and extraction in the M1's gas-operated mechanism. Quality control exceeded peacetime standards despite wartime production pressures. The maintenance requirements for the M1 proved remarkably minimal. The gas system, initially feared to be a weakness requiring constant cleaning, actually needed only basic care. Soldiers were issued cleaning kits and trained to field strip the rifle to its major components in under a minute. The trigger group, gas cylinder, and bolt could be removed and cleaned without tools. Replacement parts were standardized and readily available through the supply chain. Combat damage tests revealed exceptional durability. Rifles subjected to simulated combat abuse, including being run over by vehicles, dropped from heights, and submerged in water, continued functioning after basic cleaning. The steel receiver and barrel were nearly indestructible. Wooden stocks could crack or split, but could be replaced in minutes with standard parts. The weapon's robustness meant that rifles issued in 1943 were still in frontline service at war's end, having fired tens of thousands of rounds. The training implications of widespread M1 adoption transformed infantry doctrine. American soldiers learned to advance under fire using movement and firepower in combination. One rifleman could lay down suppressive fire while squad members maneuvered, something previously requiring dedicated machine gunners. The semi-automatic action meant soldiers could shoot, observe results, and immediately shoot again without breaking their sight picture or losing target acquisition. Marksmanship training evolved to emphasize rapid target engagement over deliberate long-range shooting. Soldiers practiced acquiring multiple targets and engaging each with 2 quick shots before moving to the next. This rapid engagement technique, impossible with bolt-action rifles, became standard American infantry doctrine. The M1's accuracy allowed this approach without sacrificing hit probability. The psychological impact on American soldiers was as significant as the tactical advantages. Infantry carrying M1 Garands reported higher confidence in firefights, knowing they could deliver overwhelming firepower immediately. The weapon's reliability meant soldiers trusted their rifles absolutely, a critical factor in combat effectiveness. Surveys of combat veterans consistently rated the M1 as their most important piece of equipment after the steel helmet. Japanese forces in the Pacific, facing M1-equipped Marines and soldiers, developed fatalistic attitudes toward infantry combat. Captured documents revealed that Japanese tactical doctrine increasingly emphasized indirect attacks, infiltration, and nighttime operations specifically to avoid American firepower advantages. Daytime frontal assaults, standard early in the war, became virtually suicidal against defenders with semi-automatic rifles. The island-hopping campaigns demonstrated the M1's versatility across different combat environments. In the jungles of New Guinea and the Philippines, where visibility was measured in yards and engagements were sudden and close range, the rapid-fire capability proved invaluable. On the open volcanic ash of Iwo Jima, where longer-range engagements occurred, the weapon's accuracy remained effective. The M1 performed equally well in tropical humidity and volcanic dust, testament to its robust design. The final campaigns in Germany showed the M1's advantages in urban warfare. Street fighting in cities like Aachen and Cologne required rapid target engagement at close range. American infantry could clear buildings and engage targets in windows faster than German defenders could respond. The semi-automatic fire meant each American rifleman was effectively worth 3 German infantrymen in close-quarter battle. Soviet observers attached to American units reported their findings to Moscow, leading to renewed Soviet interest in semi-automatic weapons. The AK-47, developed by Mikhail Kalashnikov immediately after the war, incorporated lessons learned from observing the M1's combat effectiveness. The concept of providing every infantryman with automatic or semi-automatic fire capability became universal doctrine, directly influenced by American success with the Garand. The M1's impact extended beyond World War II. The weapon remained the standard U.S. infantry rifle through the Korean War, where its firepower advantages proved decisive in defensive battles against Chinese human wave attacks. A single company of M1-equipped soldiers could generate firepower that stopped assaults by entire battalions. The rifle's 8-round capacity, criticized during development, proved adequate when soldiers were trained to reload during brief lulls in combat. The production achievement represented by 4 million M1 Garands deserves emphasis. Each rifle required precision manufacturing of 53 components, assembly by skilled workers, and testing to exacting standards. Yet American industry delivered this complex weapon in quantities that equipped not only U.S. forces, but also supplied Free French, Chinese, and other Allied armies. The production rate exceeded 300,000 rifles monthly at peak output, a manufacturing accomplishment that overshadowed even the weapon's technical achievements. The ammunition logistics were equally impressive. Each M1-equipped division required daily resupply of hundreds of thousands of rounds during combat operations. The supply chain stretched from factories in the United States across oceans to frontline units, delivering ammunition in quantities that ensured American soldiers never lacked firepower. This logistical achievement enabled the M1's tactical advantages to be fully realized in combat. The contrast with German logistics illustrated the broader disparity in industrial capacity. German forces frequently faced ammunition shortages that limited their ability to conduct sustained operations. American forces, by contrast, could expend ammunition freely, knowing resupply was certain. This difference in logistical capability, enabled by American industrial production, magnified the M1's inherent firepower advantages. Post-war analysis by military historians identified the M1 Garand as one of the decisive weapons of World War II. While tanks, aircraft, and artillery received more public attention, the rifle that armed the individual infantryman ultimately determined battlefield outcomes. The M1's firepower advantage translated directly into tactical success in countless small unit actions that collectively decided campaigns and battles. The weapon's influence on post-war rifle development was universal. Every major military power developed semi-automatic or automatic rifles in the decade following 1945. The bolt-action rifle, standard infantry armament since the 1880s, became obsolete virtually overnight. The M1 had demonstrated that semi-automatic fire was practical, reliable, and decisive. No army could afford to field infantry with inferior firepower. The M1 Garand represented American engineering philosophy and industrial capability at their finest. The weapon combined sophisticated design with manufacturing practicality, creating something that was both technically advanced and producible in massive quantities. This combination of innovation and industrial scale characterized American weapons development throughout the war and gave U.S. forces decisive material advantages. The German soldiers who first encountered concentrated M1 fire in the Hurtgen forest in November 1943 were experiencing the future of infantry combat. Their shock at the volume of fire reflected the obsolescence of their own bolt-action rifles, weapons that had served adequately in previous conflicts but were now hopelessly outclassed. Within 18 months, that initial shock had evolved into resigned acceptance that American infantry possessed fundamental firepower superiority that tactics alone couldn't overcome. The metallic ping of an ejecting en-bloc clip, initially feared to signal vulnerability during reloading, became one of the most distinctive sounds of World War II. That sound, heard on battlefields from Guadalcanal to Germany, announced the presence of American infantry and the overwhelming firepower they brought to combat. For Allied soldiers, it was the sound of security. For Axis forces, it became the sound of inevitable defeat. General Patton's assessment proved prescient. The M1 Garand was indeed the greatest battle implement of its era, not merely because of its technical sophistication, but because it embodied the industrial and tactical philosophy that won the war. 4 million rifles, each capable of delivering 6 times the firepower of contemporary weapons, armed with unlimited ammunition supplied by an unmatched industrial base, transformed American infantry into the most effective ground combat force of World War II.